Alright, so till now we have understood a concept of scatter plot, and we also understood that scatter plot is helpful when we talk about the relationship, right? And how this relationship works, right? How exactly we can find out that something is fruitful or not, is basically we can find out a couple of things. So if you're working on, or if you're looking at the scatter plot, there are three things which you would like to understand: whether the relationship is linear, right? Or I can say linearity is something which you measure, right? There could be two values, whether it is linear or it is non-linear. The second thing is that you wanted to calculate the strength of this relationship, and the next thing which you wanted to talk about is the slope. And I told you that there has to be a significance of what you are learning in all those kind of stuff, right? So what we want to talk about is something called as the mathematical entity which will define what kind of slope we are dealing with. So first thing first, if somehow I can define the relationship, so I have two variables x and y, and somehow I can define the relationship between these two, x and y, in magnitude, and somehow I can define the direction of this relationship, then I can do the job. Now what exactly this magnitude and direction means, right? So magnitude over here, this magnitude refers to the strength, okay, this strength which we are talking about, right? So magnitude refers to strength, like how strong relationship we have between x and y. And the direction is going to talk about how but like x and y are moving. Like for example, if x and y are moving in the same direction, which means x is increasing, y is also increasing. Or if x become greater, y also become greater, or vice versa, like x is going down and y is also going down, right? So we wanted to understand the magnitude and the direction both, right? And if we somehow we can define the magnitude and direction of these two entities, I would be able to successfully define this scatter plot, and I can understand the relationship between the two variables. Now if you try to find out a relationship, right? The mathematical entity which defines the relationship of x and y, relationship of x and y, is called correlation coefficient. And I want your full attention over here, okay? Coefficient. Now what is this correlation coefficient? Okay, now I just wanted to talk about this. So correlation coefficient is a mathematical entity which defines whether the relationship between the variable is linear, right? What is the magnitude of this linear relationship, or like what is the linear or not, but what is the magnitude, and what is the direction of this thing. Now you must be wondering, like, how can somebody defines that value over here, right? So let me just give you a scale over here. So if I write magnitude over here, and I would write the direction of it, let me just give you some sense, and you will automatically start making out like what exactly I mean to say, right? So if you pick up the magnitude, right? So if I say I'll just change the size of it. If I say the higher the magnitude of the value, right? If I say greater magnitude, greater the magnitude greater the magnitude, and I would say it will lead to strong or stronger relationship. And these are the things which you need to, like, I would say, do not try to remember it, try to understand it, right? Stronger relationship. Right? Now, in order to define this relationship, the value of this correlation coefficient denoted by correlation coefficient actually varies from -1 to +1. Okay, right? Which means -1 is the, like, I would say, strongest negative relationship. I'll just explain that in a bit, right? Negative relationship, and positive one is strongest positive relationship. Right? This is what we wanted to understand from the magnitude. However, this magnitude can be defined by minus or plus as well. The direction, when I say direction, negative defines, or I can say, start with positive, right? Positive defines the direction of x and y are same, or I can say, simply say, same direction. And negative defines opposite direction. The negative defines opposite direction, which means that if I have negative direction, which means that x and y are not directly correlated with each other, and they are moving in opposite direction, which means x is increasing, y is decreasing, or vice versa, right? If it is making sense to you guys, then we can probably move next towards the value, right? And what we are going to talk about is something, right? It's in this regard only. Okay, so I'm just gonna delete this value. Okay, let me just delete this value completely, and I would say that there is a specific value, there is something called as specific correlation coefficient, right? And what this correlation, let me just delete this, and I would say over here there is something called as, what we're talking about is correlation coefficient. So I will say there is correlation coefficient. Now there are many correlation coefficients which defines the values or the relationship between x and y, but the most popular correlation coefficient is Pearson correlation coefficient. Now, why this Pearson correlation coefficient is most popular? Because it is being used a lot, and it's much more easy to deal with Pearson correlation coefficient. First thing first, Pearson correlation coefficient deals with only linear relationship. So you should not be using Pearson correlation coefficient with any other relationship. The second thing, it is denoted by small r. Okay, it is denoted by small r. And the third is that the value of it ranges from -1 to +1. I would say +1, right? The value ranges from -1 to +1. Okay, I hope it is making sense. So now what we're going to understand is how this relationship works, right? So first thing first, what is this perfect positive? So this is, I told you, this is perfect positive correlationship, and this is perfect negative correlationship, right? So we have perfect negative and perfect positive. Now what is perfect positive correlationship, right? Which means that if I have a data, right, and this is my x and this is my y, and they are moving exactly in one direction, right? Something like this. So they are moving in this direction, and this direction, if the points can be represented by a straight line, all these points can be represented by a straight line, and every point falls in on the same line, then it is called perfect positive correlationship, and the value of this perfect positive correlationship will be +1. Okay, now if we have what is perfect negative, right? So let me write this: perfect negative correlationship. If I have x and I have y, this is my x, this is my y, and the points are going like this, they are following a straight line, and they can be represented by on the same line, then this is called perfect negative correlationship. Perfect negative, like, so our value will be -1, right? I hope it is making sense, right? So if this is perfect positive and perfect negative, how do you call this relationship, right? How do you call this relationship? How do you define this relationship? This is also positive. This is also positive relationship. Can I represent, and can I call this as a linear relationship? Which means that, can I represent the same phenomena via a straight line? Yes, I can represent it. It's a linear relationship. It's a positive relationship, right? What will be the R value, the strength of this relationship? So if you just follow a straight line, some points are falling on the line, some points are not necessarily always, but most of the points are nearby these points. So this is called positive, approximately 0.9 or 0.89, some sort of relationship, right? What will be a weak positive correlation? Something like this. Something like this. You can represent this as a straight line. So you can say, is it a linear relationship? Yes, it's a linear relationship. Yeah, it's not non-linear. Is it a positive relationship? Yes, it's a positive relationship. What is the value of R? It is probably 0.2 in positive. Yeah. So, right, I hope it is making sense to you, right? Now, what will happen if I wanted to create, the no relationship? How do you define no relationship, right? So let's say if I have a point, something like this, right? You cannot define if it is positive or negative, right? This is x and this is y, right? Relationship, is it linear? Don't know, right? Probably yes. You can represent it by a line. Yes, we can represent it by a line, but you don't know like where to define that line. Okay. And is it a positive relationship? Probably you don't know, right? You don't know, right, whether it is linear or not, right? 0, right? And R value will comes out to be 0.01 or something, or 0.00, something which is close to 0. Now when you say that, okay, at what point in I would say that it's a positive relationship and what is not positive relationship? Like in statistics, we consider anything above value of R should be either minus 0.3 and above or plus 0.3 and above. 0.3 and above, right? If you have a like value which is ranging from 0.3 to 0.29 to to 0 to 0.1 to 0.15 to 0.3, you will say this is insignificant relationship. We do not consider this as a relationship. So if the value of R, right, so don't worry about it, how to calculate the value of R, we will see that in programming, but I'll show you a small like demonstration on Excel sheet as well, because we haven't started the Python programming yet, or like for data science. So once you get the Python programming for data science, probably you will have a clear understanding of like how to find out the correlation. It's pretty easy, just need to put in that into the formula and you'll get that. But if you understand, like if it is going negative 0.3 to negative 0.29 to 0 to plus positive 0.1 to positive 0.5 and to 0.3, everything is insignificant there, right? We have to have a positive relationship, right? So I hope it is making sense, right? What exactly this Pearson correlation coefficient are, and how do we define the 3 points, like whether it is relationship, whether it is positive relationship, and how this whole thing works, right? I hope it is getting, you've got the clear-cut idea, right? So the more positive the correlation is, the more value will be towards the positive, the more it is like falling towards a line, the more positive the pattern would be. Now you must be wondering, like, what will happen if I have a curvilinear pattern? I'm just going to delete this. What will happen if I have a curvilinear, right? For example, if I have a graph and the points are something like this, right? So you need to understand a couple of things, right? You are trying to find out a straight line which will follow the pattern, and it is not possible for you to have a straight line which can follow the pattern, because the pattern is going something like this. So first thing first, you have a non-linear relationship, and Pearson correlation coefficient will not work over here. So even if you try to find out a correlation for that, the R value will be either 0 or it will be close to 0 for you. You would not be able to get enough the evidences to take your mathematical calculation forward, right? So for any curvilinear, or I'll just give you one more example. For example, if you have a relationship something like this, something in going in this direction, okay, then probably you will also get the value of correlation coefficient will be all. However, it is possible for you to represent this data with a line, but the value of R will be you'll be getting a very low. So in this case, it is not feasible for you to get get the correlation coefficient. Now in some of the cases, like for example in this case, something like this, if you have x and y value like this, the value of R will comes out to be 0 over here, right? It comes out to be 0, right? So you need to be very cautious about while applying the relationship, okay? So there are three pillars to identify the relationship: whether linearity, whether it is positive, is linear or non-linear; the strength, which is strong or weak; and then the slope, whether it is positive or negative. I hope it is making sense, like what this scatter plot is all about. And in the next video we'll talk about how to compute the scatter plot, and we will take a small example on Excel sheet and we'll understand the whole stuff, right? I'll see you then in the next video. Stay tuned.